So let us see the next set of questions. Fine. I have already done two series actually, two question series for electrical engineering. Now, if you didn't see them, first go watch them. After that, come to the next session. That is today's session. Fine. Let us start this session. The first question is he is asking how many number of coils will be there in a dynamometer type power factor meter for balanced three phase load. So dynamo type power factor meter, right? How many coils will be there? He is asking the question regarding the number of coils, right? Now, generally for dynamometer type meter, dynamometer type power factor meter, there will be one fixed coil, that is one current coil, and two movable coils, that is two pressure coils, right? Therefore the correct answer is one fixed coil and two movable coils, or one current coil and two pressure coils. And also this current coil will also be split into two parts actually. One current coil only will be there, but it will be split into two parts, and it will carry the current which we are about to test. It will carry the test current actually. Then pressure coil will be we will be having two pressure coils in this, and both of these will be pivoted. I mean, both are settled on the spindle, right? This is brief about power factor meter. Fine. So the answer might be one current coil and two pressure coils, right? This is the solution. Next, in a single phase power factor meter, the controlling torque is, this is the most important question actually. This was asked many times actually. This was asked many times. In a single phase power factor meter, the controlling torque is, without any second thought, go for the answer no control torque. Because because in a power factor meter there will be two coils A and B actually, two coils A and B, and these two coils will itself produce torques actually, and those torques will be equal and opposite. At steady state position or at final position, what happens is the torque produced by A will be exactly equal and opposite to that of B. So as it is, whichever the thing which is happening in the spring control, the same thing will happen. That is, the springs will be twisted in opposite direction, etc., right? Because of controlling torque will be equal to deflecting torque, the same thing. But here, without spring control, there will be two coils. These two coils will produce two torques actually. That is the explanation. So the answer will be no controlling torque, and you can see the explanation also. I wrote here with black color. You can see the explanation also. If you want, you can pause the video, and you can see I wrote the same thing which I explained here. Fine. Let us go to the next question. The internal resistance of an 0 to 50 milliampere ammeter is 40 ohm. Fine. To extend this ammeter to 0 to 150 milliampere, the shunt resistance required is dash ohm. Okay, fine. Shunt resistance required. So shunt resistance equal to meter resistance divided by M minus 1. Right. M equal to extended current by full load current. For shunt, I am saying about ammeter actually. Don't get confused. We generally use, for extending the range of ammeter, we generally use shunts, right? Now, what is the meter resistance given? Wait, wait, 1 second. Fine. He gave the meter resistance as 40 ohm divided by m minus 1. M is needed. M equal to, what is m? Wait, why it is irritating today? Fine. M is m, here I will calculate. Extended current by full load current. Fine. What is the extended range? 150 milliampere. What is the full load current in actual meter? 50 milliampere. So M will be 3. Therefore, why this is irritating me today? I didn't understand what is going on. Sorry for the disturbance actually. Let me write this again. Full load current. And M we got as 150 by 50, that is 3. And meter resistance is 40 divided by 3 minus 1. So the answer will be 20 ohm. 20 ohm will be the correct answer. Fine. Here it is. Next. A MC instrument of resistance 4 ohm, okay, meter resistance is 4 ohm, gives a full scale deflection of 20 milliampere. It is desired to convert this instrument into a voltmeter. Fine. To read up to 30 volt. Fine. Value of series resistance required is very easy. So formula is series resistance is meter resistance into M minus 1, where M is equal to extended range of voltage to full load voltage. But initially what he gave is initially what he gave is it is a ammeter actually. If you see properly, it is a ammeter and he converted it into voltmeter. He wants to convert it into voltmeter. So we need full load voltage actually. Initial full load voltage we need. So for that we know V equal to IR. We will apply that thing only here. I is 20 milliampere and R is 4 ohm. So it will be 80 milliampere. Sorry. 80 millivolt. 80 millivolt. Then coming back, he wants to extend the range to 30 volt. So if we see, what is the internal resistance he gave? Internal resistance is 4 ohm. So 4 into, what is M? Extended value is 30 divided by initial full load voltage. What we got? 80 millivolt. So the answer will be, let me calculate the answer. I didn't have the answer actually. So let me use my calci and calculate. The answer will be 1496 ohm. 1496 ohm. This is the way of solving. Actually, I am using my new version actually for the first time. So I am using this tablet for teaching for the first time actually. So I am getting a bit confused because of this tablet and all. I don't know why these are including here. So from next 2-3 videos, I will be habituated. So it will be continued. Now, sensitivity of a voltmeter using 0 to 5 milliamp meter movement is, okay, fine. Generally sensitivity, what is sensitivity? It is 1 by full load current. So we need full load, we have already given full load current is 5 milliamps. So answer will be 1 by 5 into 10 power minus 3. So it will be 1000 by 5. Answer will be 200. 200 ohm per volt. Done. This is the thing. Simple. Sensitivity, I have already made a separate video for this sensitivity. So sensitivity is nothing but it is the inverse of full load current or full scale current. Next, a 230 volt single phase watt hour meter records a constant load of 10 amperes for 10 hours. So current is 10 ampere, time is 10 hours, and power factor is unity. If the meter disk make 2000 revolutions, so number of revolutions equal to 2300. Then during this period, the meter constant is number of revolutions by kilowatt hour. So we know that meter constant. What is meter constant? It will be number of revolutions divided by kilowatt hour or energy. So for that we need to calculate the energy first. Energy in kilowatt hour is needed. So V I cos pi. Till here we got power. Now we need to multiply with time. Now we got answer. What is the answer? 23,000 watt hours. This is in watt hour, but we need to convert this into kilowatt hour. So divided by 1000. So we will be getting 23 kilowatt hour. Now he is asking for meter constant. Number of revolutions. It is 2300 divided by energy in kilowatt hour 23. So the answer will be 100. Done. The only thing we should remember here is what is the formula for meter constant, number of revolutions per kilowatt hour, and the unit will also be same, revolutions per kilowatt hour. That's it. There is nothing much to remember here. It is very simple actually. All the problems we are solving will be very simple. Before you might not know, but after this you should not forget from now. Keep this in mind. Then clamp on ammeter. This is not in your syllabus actually, but for many JE exams I saw this question actually. That's why I included this question. Clamp on ammeter is generally used for high AC currents. There are thermocouple instruments actually, there are MI instruments, but clamp on ammeter is specially used for high AC currents. This is the thing. Next. Here he gave two things, assertion and reasoning. Fine. He gave a PMMC instrument is used for reading both DC and AC signals. It is wrong. For sure, because PMMC instrument is used for reading only DC. Only DC signals. It is used for reading only DC signals. Right. So PMMC DC are average values. Fine. Next, the deflecting torque in a PMMC instrument is directly proportional to the current moving. Fine. It is correct. Deflecting torque is proportional to the current in the moving coil. So deflecting torque. What is the formula for deflecting torque in PMMC? We have already said in our paid courses actually. That will be BINA, where B will be flux density, I will be current, N will be number of turns, and A will be area of cross section. Fine. So here if you see clearly, we can see that deflecting torque will be proportional to current. So assertion is wrong and reason is right. A is wrong, but R is right. Fine. This was the previous IES question actually. All these assertion reason type questions will be seen mostly in IES question, prelims paper. So I included this question here. Fine. Let us go to the next question. Two coils are coupled in such a way that the mutual inductance between them is 16 Henry, and if the inductances of the coils are 20 Henry and other thing is 80 Henry, the coefficient of coupling is very simple. The coefficient of coupling is given by K equal to M by root L1 L2. It shows coefficient of coupling. How can you define coefficient of coupling first? Let me write that also. Coefficient of coupling is defined as amount of flux produced in one coil that links with the other coil. So generally, let me consider two coils actually. So some amount of EMF will be induced here and some flux will be created here. This is common, we know. This is because of self-induced EMF. That's all these things we know. Now, because of this flux, some flux will be linked like this with the other coil also, where we have not given any source, but this flux will link with the other coil also. So the amount of flux which is produced in this coil and which links with this coil, which is produced in one coil and links with the other coil, this is called coefficient of coupling. Fine. Coefficient of coupling is generally given as K equal to M by root L1 L2. Ideal coupling, for ideal coupling, K will be 100%. I mean, all the flux produced, I don't know why. All the flux produced in this coil will definitely completely link with this coil. That means if 10 Weber of flux is produced here, that 10 Weber will completely link with this second coil actually. In that case, we can say that it is ideal coupling. Ideal coupling, it has K equal to 100% or K equal to 1 directly we can write. And so now these coils are called magnetically coupled coils. When K equal to 1, we can call that it as magnetically coupled coils. And when K equal to 0, what does K equal to 0 mean? What does K equal to 0 mean? So here some flux is produced, and that flux, if 10 Weber is produced, no, at least not even 1 Weber will link with this second coil. That is the thing. So if 10 Weber is produced in one coil, not even 1 Weber is linking with the second coil, then we can say that K will be 0. Then we can say these coils as magnetically isolated coils. These coils are called magnetically isolated coils. But before coils, where entire flux produced in this first coil is linking with the second coil, entire flux produced in this coil is linking with this second coil. So we can say this is magnetically coupled coils. But here we can say these are magnetically isolated coils. Now let us solve the question. So K equal to M by root L1 L2. What is M? 16. Mutual inductance is 16. L1 L2. 20 into 80. It will be 16 divided by root over 600. 16 divided by 400. So what is the answer? 4 by 100. Is it right? Is it right, or did I commit any mistake? Fine, 600. So it will be, I think it will be 40, I think. Not 400, it will be 40. So 16 by 40, or we can write it as 4 by 10 or 0.4. So 0.4 is the correct answer. That means if 10 Weber is produced in this coil, then we can say that 4 Weber is linking with the second coil. That is what this coefficient of coupling means. Most of the people will not explain this in a proper way, but if you didn't understand this, please pause the video and please go for 2 minutes back and once start listening again. I am clearly saying here K equal to 0.4. That means if here in the first coil, if 10 Weber is in use, then 4 Weber will be linking with the second coil. Right? This is what coefficient of coupling means. Fine. Let us go to the next question. Why is the core of transformer built of lamination? This is very easy. Without seeing option, we can say why. To reduce eddy current loss. Without any second thought, we can say done. Answer is done, because eddy current loss equation is B max square F square T square V. So where Bmax is maximum flux density, F is frequency, T is thickness, and V is volume of core material. So eddy current loss is directly proportional to thickness. So if we reduce the thickness of lamination, then automatically eddy current loss will be reduced. That's it. Simple. Here he gave one more question. He gave in the circuit shown above, what is the value of current I? In the circuit shown above, what is the value of current I? He is asking for this current. Easy, very, very easy. Apply KCL here. Answer will be coming. So let me consider it as node A. So it will be at node A, 1 amp is coming here. 1 amp is equal to, here we need to, let me, here we have two more paths. So here two are incoming. So 1 plus I is equal to, the other path we didn't have anything. So I am writing it as I2. I2. So incoming currents equal to outgoing currents. This is what we wrote here. Now let me write the equation. 1 plus I is equal to, now if you see properly, here there is voltage source. Here there is voltage source. So the node voltage at this node point at A, what is the voltage? Voltage will be 8 volt. So now I2, what is the value of I2? Higher potential minus of lower potential. What is lower potential? Minus 2. Lower potential is minus 2 divided by 2. This is the answer. 1 plus I is equal to 8 plus 2, 10. 10 divided by 2 will be 5. So answer will be 4 ampere. Done. Very simple. Here I just applied KCL. Incoming current, sum of incoming currents. 1 amp is incoming and I is also incoming, is equal to I2. That is outgoing current. I assumed that as outgoing current. Then the answer is solved. That's it. Fine. Here, since there is no resistance and all, all the 8 volts, this voltage source is directly connected to this node point. So we can say that at this node A, the voltage will be 8 volt. That is how we solved this question. Right. Now let us go to the next question. This is also similar question. This is also a nodal analysis based question or KCL based question. So all the upper part is short circuit. So we can mark it as A. So everything will be A only here. A potential. At node A. Let me see first what he is asking. Current I is asking. Okay, fine. Current I is here. So let me solve the equation. I would like to consider this is incoming and rest they didn't give any direction. So I am assuming everything is outgoing only. Outgoing. So let me think, this is I2, this is I3. So let me write the equation, KCL equation. At node A, 70 amp is incoming and remaining all are outgoing currents. I2 plus I3 plus I. Fine. Done. We are almost done. 70 is equal to, what is I2? What is I2? Higher potential minus lower potential. VA minus 140 divided by 2. Right. Upper potential minus lower potential divided by resistance. That is the current. Plus, what is I3? Higher potential minus lower potential divided by resistance. Plus, what is the value of I? I, higher potential minus lower potential. Nothing is mentioned here. There is no source. So we will be considering this as 0 point. So higher potential minus lower potential divided by resistance. Simplify this. So the LCM will be 4 actually. 4. It will be 2 times 2 into VA minus 140. Plus it will be 4 times 4 into VA minus 70. Plus here it will be VA only. right? So multiply this, it will be 280 is equal to 2VA minus 280 plus 4VA minus 280 plus VA. Fine, it will be, I think 560 plus 280, 840 it will be, is equal to 2 plus 4 plus 1, 7 VA. So the answer will be VA is equal to 840 divided by 7. I think it will be 120 volt. At node A, the potential is 120 volt. Then he is asking for I current. So I current will be I is equal to, what is I? I is equal to VA by 4. Simply VA by 4. So 120 divided by 4. The answer is 30 ampere. Done. Simple. So in the next session we will see some more questions, how to solve some more questions corresponding to electrical engineering, right? Thank you.